So exercise 57, page 110, question number 1, plot this function. What I expect to do in this question and all the other questions on using exponential functions is to use autograph, graph plotting software, to plot the function. Unless you're particularly asked to plot it by hand, I would always use graph plotting software to do so. It's a good idea to get used to using these programs. So we're going to use autograph to plot this function. So if we fire up autograph and we get the page that looks a bit like this, we need to use this button to enter an equation, or if we go to equation there, and we would see a drop down menu and we could enter equation that way. So if we enter an equation, so type in y equals e, it recognizes e as the exponential function, to the power, which is the little hat symbol above the 6, and then all that follows in this particular case needs to go in the power. So we need to make sure autograph knows that everything that follows is in the power. We put that in a bracket, 0.2x. Autograph only recognizes y and x as variables, so in this particular case that's not a problem. But if we have a function that we want to plot that doesn't involve y and x, then we need to assign y and x to our variables and plot y against x. So we get this. Now we're interested in looking at the function over the region from x equals -3 to x equals +3. It does show it in this case as pretty well. So however, if it hadn't have done so, and you'd have had some sort of rather unusual plot, then we could have played around with it by using, so if you'd have had something like this, for example, then I can zoom in on certain parts of the graph using this button, and I can zoom box in on a particular area of interest by dragging and dropping a box around a particular area. I can also drag the graph around for the area I'm interested in. If I want to zoom in on one axis, because I'm interested actually in going from -3 to +3, which is going to be around about here, so I could do with zooming in on the x-axis, which is this button in here. So if I zoom in on the x-axis, keeping the click button roughly where I want the center of the graph to be, I can now see it's going from -3 to +3. So I could drag the graph down. I could then maybe use the zoom box tool to zoom in on that particular area of the graph from -3 to +3, which is probably around about here. Drag and drop and release gives me pretty well where it is anyway. So that's a pretty good form for the graph. And now we can use this graph to answer the question. So I'll just put this into the notes. So once I've got the graph, I could print this out, and then the question asks me to determine the value of y when x equals 1.4. So I can go up from 1.4, which is around about here somewhere, and across to determine the value of y, or I could find x when y equals 4.5. So, well, actually, I've zoomed in too far, haven't I, for that value? So let's use autograph to find this last particular part. So if I go back to here, so I'm interested in the part of the graph for the first bit when x equals 1.5, which is around about here. So I can use this zoom box tool to zoom in around about the 1.5, which is here. And I can get a pretty accurate value by continually zooming in to get the value at 1.5. So it turns out to be about 1.35 when x equals 1.5. Now to find out what's the value of x when y equals 4.5, I can zoom out. So I can get back to my graph here. And now I'm interested in y equals 4.5, so I can drag the graph down so I get the 4.5 mark shown, which is here. So again, I need to zoom out to get the graph in. So I'm interested in this particular bit of the graph when y equals 4.5. So again, I can use the zoom box tool to zoom in on that particular part of the graph. So when y equals 4.5, again, I can zoom in when y equals 4.5, I can get a value for x about 7.7. So autograph is very useful for focusing in on a graph and zooming in on a particular point of interest. And one of the drawbacks of plotting a graph of a function is accuracy. This is one way to get around that.